So in this video, I'm going to be taking two truth tables, finding the Boolean expressions for those truth tables, and then creating logic gates that satisfy the Boolean expression. So in our truth table, we're first going to look at the rows that produce a true output. And we're going to want to write an expression for it. So with the first one here, we have not A and not B and C. So that's for just this line. And that's going to give us a true output. So for our second one, we have A and not B and C. So from these two expressions, we can create our Boolean expression for the truth table. So what we have is not A and not B and C, or A and not B and C. So now what we're going to want to do is simplify this Boolean expression. So the first thing that we notice is that we have a not B and C and a not B and C on both sides. So what we're going to do is we're going to group them together. So we have not B and C, and now we're going to put the remaining A's together. So we have not A and A. So now we have a not A and A. So this expression will always be false. So now we have not B and C. And this is our final Boolean expression for this truth table. So what we're going to want to start with is putting in our B and C. So I'm going to put two positive inputs. Label it B and C. We don't need to represent A because it is not included in the Boolean expression. So now we're going to put our switches. So for B, we have not, so we're going to put a not gate at B. And for C, we just need a wire. So now we need our and we're gonna connect B and C to the and. And then we're going to put our LED to know if we got it correct. Click play. So what we want to do is, not B and C. So here we can see that it works. So now we're going to just go through each row and just make sure that the Boolean expression holds true for the entire truth table. So not B and not C, we get false, so therefore the output is 0. Not B and C, LE's on, so you get true. B and not C, false. B and C, still false. Not B and not C, false. Not B and C, true. B and not C, false. B and C, false. So this is our logic gate for this table and the Boolean expression not B and C. So now we have our second truth table. So again, we're going to write an expression for all the outputs that hold true. So for the first one, we have not A and B and not C. For the second one, we have not A, B, and C. Now for this last one, we have A and B and C. So now we can write out not A and B and not C, or not A and B and C, or A and B and C. So that is our unsimplified Boolean expression. So now we're going to want to simplify this. So what we notice is that in the first two expressions we have a not A and a B. So what we can do is put these together. So we have not A and B, or A and B and C. So now, from this can be simplified to B and not A, or A and C. So we have this because we have the B shared on both sides and the not A or A and C. So now from this, we can simplify it into B and not A or C, because the A cancels out the A. So this is our Boolean expression for the truth table. The logic gates for B and not A or C. So what we're going to start with is getting our positive inputs for each one, for A, B, and C. This time A will be included because it is in the Boolean expression. So put all the inputs. Get our labels. Put in our switches. Okay, so what we have is a not A. So we're going to get our not gate, put it on A. And then B and C we're going to leave alone. So now we're going to put our OR in for the not A or C. I'll put it down here. We're going to attach the C and not A to the OR gate. Then we're going to get an AND gate to connect the B and not A or C. And then get our LED to check if we're right. So now we're going to go through and see for all the rows this logic gate works. So, first one, 0, 0, 0. We have all these off, false. So now we have not A, not B, C, false. Not A, B, not C, true. Not A, B, C, true. A, not B, not C, false. A, not B, C, false. A, B, not C, false. And then A, B, C, true. So this is the logic gate for B and not A or C.